Okay, welcome back everyone. It gives me great pleasure to introduce the moderator for our first Nature-Based Solutions dialogue on nature-based solutions for climate change mitigation. Yadvinder Mali is Professor of Ecosystem Science at the School of Geography and the Environment at the University of Oxford and a Fellow of the Royal Society. His research focuses on the impact of global change on the ecology, structure and composition of terrestrial ecosystems, and in particular temperate and tropical forests. Yadvinder is also Programme Leader of the Ecosystems Group at the Environmental Change Institute and Director of the Oxford Centre for Tropical Forests. Over to you, Yadvinder.
Thank you, Natalie. I think you need to start my video. Somebody needs to enable it. Okay. Great. Hopefully everybody can see me. Thank you, Natalie. And it's an honour to kick off this opening panel of this digital dialogue. And in this panel, we're going to look at the role that nature-based solutions can play in the context of climate change mitigation. And the use of ecosystems to absorb some of our CO2 emissions is perhaps the nature-based solution that is attracting the highest degree of attention and excitement. It is sometimes referred to as biological carbon offsetting, although as we'll see later in the discussion, there's some debate about how exactly we define this idea of carbon offsetting. And we hear regularly grand ambitions in the context of this nature-based solution in terms of planting 1 trillion trees, arguing that carbon offsetting is both a key national and international strategy to achieve net zero and stabilize the climate, and also at a very individual level, a way of reducing your personal carbon footprint to zero. And by being a form of restoring and protecting nature, it potentially brings many other benefits, ranging from biodiversity protection and recovery through to enhanced climate resilience and through to social and economic benefits. However, recently there's also been controversy about such approaches. And this panel today is going to look at and explore and debate some of these controversies. How much can carbon offsetting really contribute to stabilizing the climate? Does carbon offsetting help or hinder the more fundamental climate goal of reaching net zero emissions? Is it a new form of medieval indulgence that enables us to continue committing our carbon sins without dealing with the fundamental issues? And a lot of the focus, when we think of carbon offsetting, we tend to think about trees. But where is it appropriate and not appropriate to plant trees? And when we look beyond tree landscapes, what is the potential and risks for non-tree ecosystems to contribute to biological carbon offsetting? So today we've assembled a wonderful list of experts who are going to dig in and explore some of these questions and debates. Some of them have diverging opinions, and we hope to have a vigorous discussion around these issues to help us think through these topics. And each of these experts will give a 7-minute presentation, and we'll just have them back to back, and then afterwards we have about half an hour of questions and answers. So please feed your questions via the Q&A chat to contribute to that question and answer session. So I'd like to kick off with our first speaker, who's Dr. Cécile Girardin, who's Science Lead of the Oxford University Biodiversity Network and Technical Director of the Nature-Based Solutions Initiative at Oxford. So over to you, Cécile.
Thank you, Yadvinder. Thanks. And what an honor it is to kick off this week's digital dialogues with the hot topic of carbon offsets. I'd like to start the session by providing a big picture perspective on this topic, and in particular on the question of how much could natural climate solutions contribute to mitigating climate change. So first, there we go. First, I'd like to clarify the definitions of natural-based solutions and natural climate solutions. Then I'd like to present the latest estimates from Bronson-Griscom's model on the mitigation potential of different natural climate solutions pathways. And finally, we propose a new framing for addressing this question by looking at it in a context that's relevant to the Paris Agreement. We ask, how can the deployment of natural climate solutions limit peak warming to well below 2 degrees C this century, whilst pursuing the efforts to limiting warming to 1.5 degrees C. So nature-based solutions are actions working with and enhancing nature for societal good. And they are an umbrella term that include ecosystem-based adaptation, ecosystem-based disaster risk reduction, green and blue infrastructure, REDD+, and many more. Natural climate solutions are a subset of nature-based solutions that aim to reduce greenhouse gas emissions. And they do so by avoiding emissions and enhancing sinks. And they are a particularly hot topic at the moment as policymakers and the private sector are adopting ambitious commitment to expand the world's forests in the coming decades. Here I'd like to present the latest estimates from the model used in Bronson Griscom et al.'s 2017 paper, which was recently updated to provide country-level estimates in Griscom et al. 2020. And here in these results, they're extrapolated to global values. So this figure shows the partitioning of cost-effective mitigation into avoided emissions and enhanced sinks. So approximately half of the natural climate solution mitigation potential comes from avoided emissions and half from enhanced sinks. And then the different pathways are grouped into actions that protect intact lands, manage working lands, and restore ecosystems. So how much land would we need to achieve this? Well, not as much as you may think, because 40% of these emissions reductions come from protecting existing ecosystems. So that's not land extensive. These are ecosystems we already have. Then about 40% come from better management of existing lands. So managing our working lands, timber, croplands, and better management of grazing lands. And only about 20% comes from restoring ecosystems. And Charlotte and Pete will talk about this a little bit more later, but that represents approximately 678 million hectares, which represents twice the size of India. So the take-home message here is that in most countries, the majority of mitigation from NCS will come from protecting and managing existing lands. So I don't have time to go into these in details, but there are a number of key constraints we need to consider when we're talking about natural climate solutions mitigation to climate change. And they include biodiversity safeguards, albedo, food security, and the complexities of governance issues. All in all, there's still confusion around the contribution of natural climate solutions to mitigation. And it's been estimated over a range of different timeframes with different model assumptions and for different objectives. So some still claim it's the best solution to climate change, whilst others that it's a dangerous distraction from the monumental task of decarbonizing our economy. And it's during one of these discussions that Professor Miles Allen suggested we answer the question in a context relevant to the Paris Agreement. So how can the deployment of natural climate solutions help limit peak warming to well below 2 degrees this century, whilst pursuing efforts to limiting warming to 1.5 degrees C? So we took this simple model that's presented in the IPCC 1.5 special report and added the results from Griscom et al.'s model that I showed before. Okay, so this is the tricky slide. I'm going to need you to focus. Please, let's ignore the lines, the faded lines in the background, and I'll use my cursor to point to what I'm talking about as I go along. So we'll focus on the gray and purple lines in the foreground here. The solid lines are the model results you'll find in the IPCC Special Report 1.5, Figure 1, Policy for Summary for Policymakers. And the dashed lines are the same models where we've added natural climate solutions as estimated by Griscom et al.'s model. So if you look at the gray solid line, this is a scenario in which we peak global warming at 1.5 in 2055 here. But if we add natural climate solutions, we reduce by this much, which in this case is 0.1 degrees C. So a significant contribution, but not as much as later on in the century. As you see here, the dashed line goes down much more significantly. So one of the messages we get from this, this analysis is that natural climate solutions are very time sensitive. And the purple line you see here is a scenario in which we peak at 2 degrees C. And the dashed line again is the same scenario where we've added natural climate solutions. And by the time we peak in 2080, we will have a reduction of 0.3 degrees C from adding natural climate solutions on a large scale. So this means we would stay well below 2 degrees C. So the two key messages here are that natural climate solution mitigation potential is time sensitive. We need to implement natural climate solutions now to get the benefits for decades to come. And that NCS will play a critical role in cooling our planet up to the end of the century. So if you see here in 2100, they will avoid up to 0.4 degrees C warming by then. So with this in mind, Simon and Bronson are now going to debate the merits and moral hazards of carbon offsets. And I'd simply like to conclude that the results I presented here clearly demonstrate that we need to shift our focus away from the carbon-centric short-term vision of increasing forest lands for carbon gains. And we need to channel this enthusiasm for nature into activities that are ecologically sound, socially just, and economically viable, into projects that improve nature and people's resilience to a rapidly changing world for the difficult decades to come. And for this, I suggest we need to focus on different metrics than carbon. Thank you.
Thank you, Cecile. And over now to Simon Lewis, who is a Professor of Global Change at University College London and at the University of Leeds. Over to you, Simon.
Hello, everyone. Morning, everyone. I hope you can see the slides. So I was asked to discuss the moral hazards of nature-based solutions. And we have a big problem in terms of climate change, that stabilizing the climate requires stabilizing greenhouse gas emissions to zero. And because there will be some residual emissions from sectors that won't get to zero, we're required to have some negative emissions to remove carbon from the atmosphere for those residual emissions to get to what's known as net zero. So there's a lot of interest and excitement, and I would say confusion about what ecosystem restoration can do to provide some of those negative emissions. We also have a basic problem in reality, that there are very powerful actors that have repeatedly sabotaged emissions reductions plans. We've known that there's a serious problem. We've had global discussions since 1990 and formal discussions since 1995 to control climate change, but 50% of all fossil fuel emissions in all of human history have been emitted since 1990. And now, today, fossil fuel companies, airlines and the like, are talking about nature-based solutions and natural climate solutions as a way of delaying climate action, just as they've delayed climate action in the past. It's a big talking point because environmentalists, ecologists, many scientists are interested in restoring nature, but this is now being, in my view, by some actors being weaponized to avoid taking the action required to reduce emissions down to net zero. So with that in mind, here's one example from recently in the UK. So Shell, you can go to a Shell garage, you can fill up your car with fuel, and then Shell will go and plant a tree on your behalf to make you carbon neutral driving. Now this is predatory delay, is against the transition required to move to electric vehicles. This is telling people they can plant trees to continue as they were before. So with this big hazard in mind, I want to briefly discuss what I think that natural climate solutions can do and what they can't do. So natural climate solutions for carbon removal have a limitation about that there's a finite amount of land, and Earth is very well used. Lots of people are using almost all the land on Earth. There is not lots of spare land. What often looks like spare land, particularly in the tropics, is used often by some of the most marginalized people on Earth. So if we take that land away and plant trees on it to sequester carbon for example, drivers or people flying in airplanes in the global north, and that could, it's a big hazard in terms of negatively impacting some of the most marginalized people on Earth. So that has to be really carefully thought about and local people led for these nature-based solutions on the ground. Second, if we want to allocate more land to nature to sequester carbon and all the other many benefits we get from nature, that's going to require reducing farm and food waste and taking land that is used very inefficiently, mostly to produce meat and dairy, and change our diets to reduce the amount of meat and dairy in our diets. So these are all difficult, complex problems to solve, and that's planting trees is not an easy solution. So if we do not go down this route and allocate land to nature without making these changes, then food prices will go up, and that's another hazard in that the world's income poor people will see big impacts on themselves from this move of land from food production to nature if it goes through price. The final kind of group of hazards associated with carbon removal from nature-based solutions is that taking fossil carbon that's gone into the atmosphere and moving it and trying to store it in biological systems is inherently less stable than keeping carbon in the ground. And that's because this carbon in new ecosystems needs to be protected in perpetuity, and it needs to be protected from future land use change, future decisions to change the land use from forest to some non-forest land use, and that carbon go back into the atmosphere, or forest fires, which we may see increase into the future, or at least require very careful management as Earth warms and we see periodic droughts and other weather extremes. So with that in mind, I think it's worth revisiting the slide that Cecile just showed, which is this headline figure of 30% of the near-term mitigation effort and 11 billion tons of carbon dioxide equivalent per year being removed, or apparently removed through nature-based solutions, is actually a more complex and more nuanced figure. Firstly, about a third of that reduction is from protecting ecosystems, and a third of it is from improved management. And those are largely baked into scenarios going forward in terms of the IPCC scenarios from representative concentration pathway 2.6 to meet 2 degrees target already assumes after 2035 that there's almost no deforestation happening. The new part is this 1/3 of increasing forest and wetlands and restoring them back to their natural cover, which is about 3.6 billion tons of carbon dioxide equivalent each year. So is about 9% of global carbon dioxide emissions. So the other 90% is going to have to come from reductions in fossil fuel use or other ways of removing carbon from the atmosphere. So these headline numbers, I think, can be misinterpreted because only a fraction of that is actually about removal of carbon from the atmosphere rather than reducing the emissions from the land use sector. We can look at these nature-based solutions in context. Last year, the IPCC, Intergovernmental Panel on Climate Change, produced a special report on land and climate change. And if we look at those figures of the gigatons, billion tons of carbon dioxide equivalent, currently emitting about 4.9 billion tons of CO2 from land use change. If we take nature-based solutions from Griscom's numbers, that gets reduced to 1. If we look at agriculture, we're seeing from all greenhouse gases, 6.2 billion tons of carbon dioxide equivalent emitted each year, and that would go down to 2.4 billion tons. For restoration, so that currently the restored numbers are inside the land use change numbers in the IPCC report. If that goes down by 3.6 billion gigatons, billion tons of carbon dioxide equivalent, then the net impact of doing all nature-based solutions across protecting, managing, and restoring habitat gives us a net impact of you can make land use, food production for the world, and forestry, all the timber products and other products from the world, net zero. But that leaves all other sectors needing to get to net zero by themselves without relying on nature-based solutions. So in terms of these moral hazards and all of the interest from many different industries about offsets using nature, then if we prioritized offsetting just the very residual emissions from feeding the world, then there is no space left in terms of space to restore habitat for all the other industries. So I think that's the kind of, to me, the big moral hazard of doing the essential work of restoring ecosystems for adaptation, for biodiversity, for economic benefits, for all the ecosystem service benefits, is essential, but we shouldn't get blinded to the fact that these are limited, and almost all industries and almost all sectors are going to have to get down to net zero without relying on restoring ecosystems to offset their emissions. And I'm very happy to take any questions. Thank you very much.
Okay, thank you very much, Simon. And now we'll move on to our next speaker, Dr. Bronson Griscom from Conservation International, who will, or you heard his name a few times in the previous two talks, and he'll present his perspective on all these debates. Over to you, Bronson.
Thank you so much, Yadvinder. I'm just trying to start my video. I think it's still blocked. Well, it's a tremendous honor and pleasure to be part of this this session, and I want to start just by agreeing on the fundamentals here, and I think there's a lot more agreement than there is disagreement. I think so. To be clear, I think we all agree on the fundamentals. Let's just say, I assume we do, that we need to get to well below 2 degrees. And I'm here to speak for myself. I work at Conservation International, but I'm just here to speak for myself. But what I can say is that you know, myself and everyone at CI and frankly all of the other nonprofit environmental organizations that I, you know, folks that I work with, are deeply committed to fundamentally what Simon was talking about, right? Which is that we cannot delay climate action in reducing fossil fuel emissions by using natural climate solutions as a distraction from that. So full agreement. I know agreement is not as interesting as debate, so I'm going to now make an effort to debate some points, or at least kind of provide my perspective, which is not, the same as Simon's, despite that broader agreement. And so with that in mind, I think that the first point is a point of emphasis, which is I think that there's been a lot of focus that I've seen in the literature about concerns that NCS is used as a distraction. I actually, and again, I agree with that fundamental concern. We have to constrain the use of offsets so that they're not done in that way. We have to insist and push as hard as we can to get fossil fuel companies and others to drive down their emissions and get, as aggressively as possible. Having said that, currently natural climate solutions receive less than 3% of global investments in climate mitigation. Their potential cost-effective contribution to climate mitigation in the near term is about an order of magnitude greater than that. So right now, the level of investment in NCS, NCS is essentially an orphan in the current sort of portfolio of investments, across the board, whether it's public investments, private sector investments. So I actually think that there's a greater concern. Essentially, there's an additional moral hazard. The additional moral hazard is that we leave natural climate solutions on the sidelines because a large portion of natural climate solutions are essentially not part of, they're sort of on the margins of what is perceived as economic development. They're deeply embedded in economic development, but they're just perceived as sort of, not the cutting edge technology, et cetera. Okay, so point number one is that it's a both and argument, is we have to do two things at once. We have to ratchet down fossil fuel emissions aggressively. We have to ratchet up natural climate solutions aggressively. Second point, and I'm going to try to share my screen to do this. I'm just going to show you one slide. Hopefully you can see this. It's actually a slide from a colleague of mine, Ruben Lebowski. And this is saying, okay, so how do we do this? How do we ratchet up natural climate solutions while ratcheting down fossil fuel emissions? I think the argument about offsets is, as far as I can tell, an argument about to the extent to which we include carbon markets more broadly across any sector. And I'm not an economist, but economist colleagues of mine have done a number of analyses on these. And the basic concept is this in this slide, is that the current policies shown on the left, this is essentially the Paris Agreement pledges that we have from a large number of countries. Obviously, these are pledges; these haven't been delivered on. But if we estimate the cost of delivering on those pledges, and then we ask the question, what if countries were permitted to trade, so that they could essentially more cost effectively, when you trade essentially within carbon markets, it allows you to essentially deliver a given climate mitigation outcome with a larger number of low cost options. Okay, that's what essentially trading is designed to do. And the conclusion of their analysis is that you can substantially, in fact, nearly double the amount of climate mitigation for a given cost, given willingness to pay by society, by allowing carbon markets, and furthermore, by including forests in those markets, you can dramatically increase the magnitude of climate mitigation that can be delivered. Now that's, by the way, just including forests, which is about 70% of what we define as natural climate solutions. So this is actually an underestimate of the potential for natural climate solutions to be included, to increase climate outcomes in the near term, again, with various assumptions about cost constraints. Okay, so carbon markets are very useful in a pragmatic sense at delivering a more outcome for a given sort of, let's just say, pain threshold that society has. So the key is that these are done right. So how do you do carbon markets right. So they're both regulatory approaches to carbon markets, essentially government pseudo markets, and they're voluntary markets. We don't have time, to sort of go into the variety of details, but to me, the key argument and my key response to Simon is that, absolutely agreed, we can't do them wrong. They can't, be used as a distraction, essentially a greenwashing. But there are a number of opportunities, and we've come a long way over the past decade to do them right. There's CCB standard for climate community and biodiversity, certification process to make sure that that voluntary carbon projects are done right. There's Vera Carbon standard, which is one of the strongest scientifically based standards available to do this. These are very robust and they can be done right. But we must be careful. We must be strict. We must do it right. So, bottom line is, I think that all of the above should be done. We need regulations. We need trading markets. We need voluntary in the near term, and we should ratchet down voluntary as we proceed to hold both our own feet to the fire and corporates' feet to the fire. But we need all these things, and essentially we don't have the luxury anymore of sort of just doing, one approach or another approach. I think we should do all approaches and do them as well as we can. Thank you.
Okay. Thank you, Bronson. Okay, so now we'll move on to our next speaker, Dr. Charlotte Wheeler, who's a postdoctoral research associate at the University of Edinburgh, and she'll look at where it is not appropriate to plant trees. Over to you, Charlotte.
Hi, good afternoon, everyone. I'll just share this. Right, so good afternoon, everyone. I'm Charlotte Wheeler, and I'm going to be talking to you about some of the potential problems with tree planting schemes and how they could possibly be counterproductive to climate goals. So firstly, to give some context into the carbon sequestration potential of reforestation as a nature-based solution. Firstly, I'm sure you're all familiar with the large area of opportunity that's somewhat controversially been estimated to be available for restoration, so between 0.9 and 2 billion hectares of land globally. And this is coupled with a large carbon sequestration potential. So research from fellow panelist Bronson suggests that reforestation has the highest climate mitigation potential of any nature-based solution. And various studies which have tried to quantify carbon sequestration from restoration have put that somewhere in the region of 100 petagrams of carbon by the end of the century. And this huge potential has gained very widespread support from governments, NGOs, and also the general public, and has led to these very ambitious global targets such as the Bonn Challenge. But the discourse is also quite heavily framed around tree planting, such as the Trillion Trees campaign, Ethiopia's claimed to have planted 350 million trees in a day last year. So in this race to plant the most trees, are we really ensuring that tree planting will achieve its full carbon sequestration? Now, there are some specific circumstances we need to consider when planning tree planting schemes. One of these is afforestation in non-forested biomes. Grasslands are of particular importance here, which are widespread in Africa. Large areas have been identified as suitable for restoration are actually located within grassy biomes. This does essentially mean afforesting areas which haven't previously had forest cover. Now, mapping efforts have often assumed that native grasslands are actually deforested or degraded forest landscapes. So they have climates which could technically support forests. But whilst this may be true in theory, this assumption doesn't account for the influence of fire and herbivory on grassy biomes that limit tree growth. And afforestation within these areas can have very negative consequences. Firstly, they're home to nearly 300 million people, which can have serious impacts on their like land tenure rights. It's also home to a diverse megafauna, and differences between trees and grasses in terms of their water use and carbon allocation can influence ecosystem services. And within these within these fire-dominated systems, plantations are very vulnerable to fire, whereas native grasslands, which store most of the carbon below ground, are far more used to these environments. And similar negative impacts can also be seen within other non-forested biomes, such as peatlands, for example. So essentially planting within these non-forested biomes really must be avoided. However, we're not just talking about tree planting within non-forest biomes. There are other forms of restoration we need to talk about. So this includes natural regeneration, restoration of ecologically important habitats such as mangroves, wildlife corridors, buffer zones, and also agroforestry. And the differences between carbon sequestration, these different forms of restoration, is something that we really need to understand. So how can the type of restoration actually influence carbon? Well, when it comes to afforestation, the likelihood is that this will be primarily fast-growing monoculture plantations. And these are very appealing as they have very fast rates of carbon sequestration, which are higher than naturally regenerating forests. And they also produce cash crops at the end of a rotation. But we need to consider the permanence of carbon stocks. So in terms of plantations, these trees will be cut at the end of a rotation period, which is typically about 10 to 15 years for many species. Whereas natural regeneration represents a much more permanent and long-term carbon stock. These forests can continue sequestering for many decades, and assuming they're protected, they can attain very high carbon stocks. However, we do know that natural regeneration won't happen everywhere. Research we published last year showed that 45% of current commitments are for plantations versus 34% for natural regeneration. But it's really important here to highlight the fact that the carbon sequestration potential of restoration is often based on numbers for intact forests. So this assumes that areas which have been reforested are recovering back to an intact state. And this brings a discrepancy between the predicted carbon sequestration potential that's been estimated and the reality on the ground. So in our research, we showed that based on current commitments, carbon sequestration is about 2/3 lower than if land were all allowed to be regenerating back to a natural state. So why is there such a difference in this in the carbon stocks? Well, a lot of this is to do with accounting for the initial standing stock on the land. And we need to think about this very carefully if we're to determine the best trajectory for a piece of land. So in areas that are, starting with a low stock of carbon, so this could be agricultural lands which are no longer productive, fallow lands, recently cleared forests, then afforestation with plantation species could be a suitable a way of sequestering carbon. In agricultural landscapes, agroforestry could be promoted to increase carbon storage within currently used agricultural landscapes. But when you look at degraded forests, which have a moderate standing carbon stock to begin with, we need to be very careful and we need to make sure that we're enhancing and building upon these carbon stocks to promote natural regeneration and encourage the expansion of natural forests, and be careful to avoid replacing degraded forests with plantations. A recent study from Chile showed that a forest subsidy scheme which promoted the expansion of over 1 million hectares of plantations since the 1980s actually led to a source of carbon emissions. And this was primarily due to the replacement of native forests with plantations. However, if this scheme had been properly enforced and plantation expansion was not allowed to happen at the expense of native forests, then this scheme would have led to large carbon sequestration. So this really highlights the importance of making sure that degraded forests, which have some level of carbon standing on the landscape, are not replaced with a plantation species. This can be really detrimental. So in terms of actually tree planting being counterproductive to climate goals, well, I think it's very unlikely that widespread tree planting wouldn't sequester some level of atmospheric CO2, and the exact scale of this sequestration is very dependent on the type of restoration we undertake. But we really need to build on enhancing current carbon stocks and only put plantations where they're appropriate, and definitely not on naturally non-forested biomes. But the problems only really arise when we rely too heavily on tree planting at the expense of cutting fossil fuel emissions. But the likely carbon sequestration potential of reforestation in no way can justify any delay in reducing fossil fuel use. Okay, thank you.
Okay. Thank you, Charlotte. And over to our final speaker, Professor Pete Smith from the University of Aberdeen, who will talk about the potential in non-tree landscapes. And Charlotte, if you stop sharing your screen, you have already. Okay, great. Over to Pete.
Thank you, Advinda. So Charlotte's already covered the forested land, so I'm just going to give you a quick whistle-stop tour through the nature-based solutions on non-forest land. Let's see if I can get it to move. I can't. I'll go back in and start sharing again, and hopefully it will move there.
For me, it was only moving when I was clicking on the mouse.
Okay. That's annoying.
Maybe just show it at this mode, Pete, if it doesn't go in
That's
slideshow
going.
for some reason.
Okay, that's going now, Yadvinda. Thank you. Sorry for that hitch. Right, so I'll be talking about the non-forested land. So Charlotte has already covered what can and can't be done on the forests. That's been very good. I'd just like to cover some of the other solutions, particularly in agricultural land, wetlands and peatlands, and soils as a specific case. So I'm showing the results here from the oft-mentioned Griscom study from 2017, but I'm going to focus on the middle section, agricultural land, and on the bottom section, the coastal and wetland and peatland restoration. So the first is nature-based solutions in wetlands and peatlands. So since the study by Griscom et al. 2017, there's been a revision in one of these figures for the coastal restoration figure, and that's a little bit lower than was originally estimated. But you can see that overall, if we look at both coastal restoration and peat restoration, so an active management to increase those areas, and also the avoided impacts by avoiding conversion of peatlands and coastal areas, then we have a total technical potential of about 4.5 gigatons of CO2 equivalents per year. So that's a technical potential, and that's not entirely an economic potential. But you can see there's some significant potential there. So we can manage our wetlands and peatlands better, particularly those that have been degraded. So I'm thinking of the tropical peatlands, particularly in sub-Saharan Africa and Southeast Asia, which are exploited for food and other cash crops. But also some areas in the boreal region where the peatlands are exploited for agriculture. There are lots of degraded peatlands and wetlands that could be restored, give us some potential for carbon mitigation, climate mitigation. The other solutions that were considered in the original study were in agriculture. So some of these include improved nutrient management, grazing, conservation agriculture, improved rice management, and grazing land management, for example, but also trees in cropland, so that's agroforestry. And the potential there has been revised upwards in Griscom et al. 2020 to a higher global potential for agroforestry. And when we put all of these nature-based solutions together on the managed agricultural land, we come up with a technical potential of about 4.4 to 6.9 gigatons of CO2 equivalents per year. So again, that's a significant potential if we can manage our land better to increase carbon sinks and to reduce the emissions. So another thing that we can look at is we can look at the soils component of all nature-based solutions. And if we look at just the soils component, this was a paper published just this year by Deborah Bossio et al. In Nature Sustainability. Soil carbon comprises about 9% of the mitigation potential that's available from nature-based solutions in forests, whereas in wetland it's about 72% of the potential, because most of that carbon is stored in the soil, and it represents about 47% of the potential that's available in croplands and grasslands. And the total technical potential then is for soils about 5.5 gigatons of CO2 equivalents per year, which is very consistent with other studies that have recently estimated the potentials. So we tend to talk about afforestation and reforestation as these are the sort of the figurehead for many nature-based solutions. But the point of this talk is just to show you that there are a whole bunch of other nature-based interventions that we can make on current agricultural land and peatlands or wetlands, which could contribute significantly to the overall mitigation potential. We can also look, as Cecile said, we must look at other things other than just carbon as a metric for nature-based solutions. And one way of doing that is to look at contribution of the nature-based solutions to other ecosystem services and to the sustainable development goals. So here's a horrible pizza diagram that looks at, I'll just give you two examples. I'll give you wetland restoration and soil carbon sequestration. If you look at the figure here, we've got wetland restoration in the center. These are the functions provided by wetland restoration. So there's things like climate mitigation, flood abatement, habitats for biodiversity, recreation. So we've got 6 functions that are broadly associated with wetland restoration. We can have a look then at how each of those functions contribute to the nature's contributions to people, i.e. the ecosystem services. So each of these ecosystem services is underpinned by a number of these functions. So if we look at, for example, regulation of freshwater quantity, location and timing, we can see that functions 2 and 3 of wetland restoration contribute to this particular ecosystem service. That's the middle row of the pizza. If we then look at the outer row of the pizza, these are the 17 UN Sustainable Development Goals, and we can have a look at which ecosystem services provided in the middle ring of the pizza contribute to each of the Sustainable Development Goals. And you can see that a whole bunch of these ecosystem services underpin one by one each of the Sustainable Development Goals. So this gives us a conceptual way of working out from the functions through the ecosystem services to the impacts on the Sustainable Development Goals. As you can see, most of these are positive. So we have large positive effects on most of the Sustainable Development Goals, but there are some potential negative impacts, for example, on zero hunger. Very locally, we could find interruptions in food security where the current wetlands and peatlands are being used for food production. So, for example, in Southeast Asia, where some of the land is being used for food production, for some restoration of mangroves could impede shrimp farm development, for example. Locally, that could cause negative impacts. And it could also cause negative impacts locally on some economic growth, where the economic growth in the wetlands is driving the expansion. So just one or two small downsides, but broadly very positive upsides and co-benefits associated with wetland restoration. It's a similar picture for carbon, soil carbon sequestration. And the good thing about soil carbon sequestration is that it doesn't compete for land. You can improve the soil organic matter content and sequester carbon without changing the land use. So you can still use the food land for producing food without taking the land out of production. So you can see that it provides a whole range of ecosystem services. It supports a whole range of the Sustainable Development Goals, And for everyone that we can assess, these are entirely positive. So the take-home message from this is that soil carbon sequestration is a good thing, whether you do it for climate mitigation or for many other purposes. There are really so many co-benefits that even if you weren't trying to address climate change, soil carbon sequestration would be a great option for addressing the many other ecosystem services and the Sustainable Development Goals. So I'm just giving these as a couple of examples of areas where you say if you have reservations about nature-based solutions as an efficient solution for climate mitigation, there are a whole bunch of other reasons for doing them. So in summary, I'd say that the land as a whole has a vital role to play in climate change mitigation. But while it's got an important role to play, I think this has been emphasised time and time again in the presentations that we've had, we can't do it all with the land. So we need immediate and aggressive greenhouse gas emission reduction across all sectors. And the nature-based solutions should come as an addition to that, not in place of them. Many options for climate change mitigation in the food sector and the food system deliver a range of co-benefits for ecosystem services and the SDGs. And there are a few potential negative side effects. So that means that we either don't do a nature-based solution in an area, or that we try to manage minimize and manage the potential adverse side effects. And I'd like to finish by suggesting that we need to look at the land as a whole. We don't just look at the natural land as something that we do, that we use for climate change mitigation or nature-based solutions. A number of interventions in the food system, such as dietary change towards lower consumption of meat and dairy, and a higher proportion of plant-based products in the diet, and food waste reduction, free a huge land area. About 30% of the crops we grow on the planet are used to feed livestock when we could be consuming those products directly. And large areas of grazing land are used inefficiently by grazing ruminants, which we could use more effectively for other things. So if we were able to free that land through dietary change and food waste reduction, then that land that's freed by dietary change or food waste reduction could be used for reforestation, for wetland restoration, and for a whole range of other ecosystem services. So we mustn't look at these nature-based solutions in isolation. We should have a look at the food system and the wider uses of the land to see where we can leverage options which allow us a greater potential, to give us more headspace to do those nature-based solutions more widely. And I'll leave it there.
Okay, thanks very much, Pete. So now we'll move on to an open Q&A session. We have about just under 20 minutes for this part, and there's been a range of questions coming in on the Q&A, and I'll try and filter and channel some of those through to the speakers. And so I'll kick off with a question of my own first, and it seems to me a key nub question that cuts across many of these talks is, to what extent is deployment of nature-based solutions causing a delay in the fundamental fossil fuel problem, or is it just one of the complementary strategies that we need to reduce emissions across multiple sectors such as transport and industry and heating, and nature-based solutions is just one of those sectors that we have to work with? And we've heard arguments on both sides there, but what I'd like to ask is, is there evidence to support the arguments either ways? Do we have actual evidence that a focus on nature-based solutions over the last 10, 20 years has causally caused a decreased focus on fossil fuels, or vice versa, that we see that is there evidence of it being complementary and not affecting it? I guess this is directed mostly at Simon and Bronson, but others may have viewpoints on that.
Well, I think the focus on nature-based solutions has been very recent, and there's a big push at the side events of the UN climate change talks by the fossil fuel industry companies to push nature-based solutions. And if they were serious actors in terms of getting their emissions down to net zero, they would be making big investments in structural changes to their business model to get those emissions down, rather than trying to outsource the problem to planting trees in the global south, for example. It sort of reminds me a little bit of the excitement more than a decade ago that reducing emissions from deforestation and degradation, the RED debate, would provide this really cheap, really easy way to reduce emissions. And here we are a decade and a half later, and emissions from deforestation are almost at record levels. They're as high as they've as they've been in the recent past, and we haven't seen that easy, cheap, quick switch to almost no emissions from deforestation. I think I should hand over to Bronson.
Thanks, Bronson.
Yeah, I mean, I can just adding to Simon's point, when I again sort of conceptually agree on the broader points Simon's making. I would add that there have been some, I think, some exciting both national examples of major outcomes that did not reduce or undermine fossil fuel emission reduction. So in the case of Brazil, in the last decade, there was a major reduction in deforestation emissions from Brazil, which contributes a large portion of global deforestation. So it was a contribution to global deforestation emission reductions due to primarily improved policy. And obviously that, as we see now, and as I mentioned, that has now, backslid, unfortunately. But we had a period of time where it was demonstrated, by the Brazilian government that, by a combination of some of the best monitoring and rigorous monitoring and tracking systems that the Brazilian government has, and strong governance, they were able to dramatically reduce emissions, and that was not as a sort of done as somehow offsetting fossil fuel emission reductions. So at the project level, so in terms of voluntary offsets, what I would say is that I think there are examples in both directions, right? There are examples of bad projects, and there are examples of very good projects. So I do think there is, just demonstration of both sides of this coin. And having said that, again, I think seconding a point Simon said, and a point I made earlier, we have yet to invest in natural climate solutions of any kinds, various kinds discussed by various folks here, at the level at which we frankly have empirical evidence at a sufficient scale to answer the question that has been posed in this panel. So we certainly need that evidence, and we certainly need to increase the investments in order to explore the answer to your question.
Thank you.
And I would just add overall, the issue is that every sector in every country needs to get to net zero emissions, and every country and every sector thinks that they shouldn't be the ones to get right to zero. And that someone somewhere should remove carbon from the atmosphere to help them get to net zero. And my point about nature-based solutions is that they can't do that for everyone, for all these different sectors and all these different countries. But they can do a slice, and you get enormous co-benefits from them, really enormous, that you don't get from the other ways of removing carbon from the atmosphere.
And forgive me for also jumping in again one last time, but what I would emphasize is that in these conversations, it is often, I think, presented as NCS as kind of this kind of sort of, well, do we do it or do we not do it, as it's sort of an additional thing to fossil fuel emission reductions. In a large portion of tropical countries, as well as other countries, but tropics is an area that I've focused on. NCS is the largest piece of their solution set. So it's not, I think, you know, the whole notion that NCS is kind of this other piece that could or could not be added on, for many countries, that's just not the reality. It is, in fact, in a lot of tribal countries, as well as some other developing countries in particular, you know, the largest opportunity, the main dish, and a huge opportunity, I would say, if you have trading mechanisms, good ones, to actually get investment from wealthier countries to move towards developing countries, which is, you know, for all the reasons I think Pete, you know, there are a whole variety of stories about sustainable development goals that can be brought in here that are aligned with that investment.
So I wanted to ask then, in that case, if they are the largest piece in some countries and we accept that they do have a lot of potential, then the question becomes, how do we ensure that the finance goes to the right projects, to the right nature-based solutions projects? And do you not think in that case that focusing on carbon might be restrictive and might lead to what we've seen in terms of investing in afforestation for carbon benefits rather than looking at all the other benefits?
Oh, you mean focusing investment in sort of the carbon angle on forests rather than the other, right? The other. So, yeah. Well, I would say absolutely. I mean, here again, like both and, right? I mean, there's no, I mean, to the extent that there is financing and investment available to invest in conservation, restoration, improved management of lands for all their other benefits, water, all the things that Pete, you know, indicated, couldn't agree more. I think, you know, let's absolutely do that. I think what I would argue is that there is an additional piece of major financing that is on the table increasingly right now. Okay, that is additional to funding available for water funds and for biodiversity conservation, all these things. It is additional to that. And what I think a lot of folks are debating is like, well, is that kind of a perverse thing to, you know, to allow that additional investment in protecting forest, restoring forest, and other ecosystems? And I would argue it can be, and we have to be very careful about that, and we have to make sure it's not greenwashing. But if it's done right, and there's the tools now available to do it right, and there are lots of examples of how to do it right, if it's done right, it can transform conservation as we know it. It's a huge amount of, you know, small proportion of what we're calling offsets can really dramatically in the near term, you know, transform conservation as we know it. And to me, that's a very exciting opportunity with all the risks and concerns that have been mentioned. You know, agreeing with that, we have to do it right. So I guess what I'm saying is, again, I don't think it's like, you know, is it like either carbon or water? You know, it's wherever we can get funding to do these things, let's do it, and let's do it right. But I think the reality is that the amount of funding on the table for carbon is just quite a bit more than as far as I'm aware, than for these other things. So that's why, hence, you know, this topic of this debate.
Okay, thanks, Vincent. Okay, I'll move the questions in a different direction now, and I'll direct the next question to Charlotte and Pete. And this is channeling a modifying a question sent by Emily Warner, which is a number of the talks here have talked about some of the issues about choosing where to plant trees, where to do ecosystem restoration, and some of the problems there. But often the messaging, as we've heard, can often be very simplistic and very focused on trees. So how effective are these more nuanced messages in getting out there in terms of the discussion around where it is appropriate and isn't appropriate, and how can we be more effective in getting some of these more nuanced messaging through to policymakers and activists and others?
Charlotte, do you want to go first?
I can do. I think, like you said, there's a lot of the discourse I find around this area is related very heavily with tree planting, and I think that's because it's seemingly really simple. You know, you plant trees, they sequester carbon, and that helps solve climate mitigation. But obviously, as soon as you start looking into it in more detail, you can see there's so many complications that need to be considered. And I actually think that those nuanced arguments probably aren't getting out as much as they need to, and selecting sort of the right places and locations for doing different activities is maybe not being considered in the level and the way that it needs to be. Obviously, we had a very limited amount of time to go over the various subjects we were talking about. So we didn't really get the opportunity to talk about some other things, particularly when you're looking at forest types of restoration, about planning these things at a landscape scale, because thinking about, you know, tree planting schemes at a very site level really isn't very helpful, because, you know, as people have mentioned before, none of these landscapes we're talking about are empty. They all have current uses and functions, and we need to think about what they're being used for now and what the best trajectory for various different parts of land for. And in marginal lands, maybe that is, you know, regeneration back to natural forests and all of the many ecosystem services that they provide, and we all know that they provide, but we need to be very careful about considering the people that live within these landscapes. You know, there are hundreds of millions of people that rely on forests for their livelihoods, and if we start undertaking wide-scale tree planting, then, you know, human rights may be violated quite badly by blocking access to important resources for many people. So to go back to the question of, I guess, how do we add the nuance into the conversation? I mean, I think forums like this are really important. With airing all of the different nuances is researched and to a more broad audience, then I think that's a really important way for us to try and get the complexities across to a wide range of people.
Yeah, I'd add to that. I think forests or tree planting has captured the imagination because everybody loves trees. Everybody can see trees and everybody loves them. So there was a good example in the last UK election where the major parties were outbidding each other on the number of trees that they would plant. So I think it's just an easy thing for people to understand until you start to look behind it, as Charlotte's already said, about where it's appropriate to do those things. But the reason I gave that little talk was to show that there are other things outside afforestation, reforestation that we need to consider. There are other ecosystems which we can intervene in and do nature-based solutions to manage the land more effectively, particularly wetlands and in agriculture. Particularly, I think the ones that don't compete for land. So with trees, you have this problem about that they're competing with other ecosystem services or other services such as food production. But things like soil carbon sequestration and putting trees in agricultural landscapes through agroforestry, you can basically get the best of both worlds. So you don't have to compromise on food production. You don't have to compromise on productivity. And if we can find a way of doing those things, as well as some targeted reforestation and some targeted wetland restoration, I think that would be a good thing for many purposes. I'd just like to say also with the point about do we accept money from big oil and other polluting industries to spend on nature-based solutions. I personally don't have an option with taking their money and using it to do that. But the insidious thing and the problematic thing is when that money is tied to the persisting emission of greenhouse gases. So when it's linked to you buy a litre of petrol and you get so much of a carbon offset, then we're linking the continued emission of greenhouse gases with the nature-based solution. And that's entirely wrong, and that will push climate mitigation in the wrong way. So I think if it's not linked to that, if the heavy emitting industries want to provide money on a voluntary basis, then we should take their money. But the problem comes if it's linked with the ongoing greenhouse gas emissions. And that's when I think we have to seriously question whether taking the money is a good thing.
Thank you. Okay, I'll follow up with a question, a version of the question from Laura England, which is about the role of diet. So we've heard a few points made about there not being that much land available because lots of marginal, impoverished landowners often use these lands that are marginal. But when we look at, particularly Europe or North America, we know that beef consumption, in particular meat consumption, has a particularly large land footprint. And I'm not sure to what extent these are already factored into these calculations. To what extent is there potential for dietary shift to make the land available that could facilitate extensive nature-based solutions in Europe or in North America? Pete?
Yeah, can I take that one, Yadvinda? Yeah. So Stephanie Rowe et al.'s paper last year in Nature Climate Change looked at the pathway, what the land sector would look like if we were to try and hit a 1.5 degree target, the most stringent of the Paris goals. And one of the critical components of that is a shift towards 50% of the people having almost entirely plant-based diets. So that could be 50% of people, or it could be a larger proportion just having a lot less meat consumption in the diets, meat and dairy. So it is a vital component, both for its direct emission reduction potential, livestock products on a kilogram per kilogram basis, on a kilogram of greenhouse gas emissions per kilogram of product. Ruminant meat, for example, is about 10 to 100 times worse than plant-based foods. So it's a really important thing, both for a direct emission reduction and for freeing the land, because animal-based products take about, again, it's 10 to 100 times more land to produce a unit of product. That's a huge amount of land that we could spare. We could regard that as spare land if we all changed our diets. So I think it's a critical component, hugely, hugely difficult to do. And it's there are some areas of the world we shouldn't forget where people are not getting enough food. So I think in some areas of the world, we might be suggesting that there could be, slightly more livestock production, but the over-consuming countries, particularly developed and middle-income countries, we could make a huge reduction in our livestock product consumption, which would be better for our health as well as the planet. So I think we must try and find ways of addressing that.
Thank you.
Could I just add to that, we obviously need a shift in consumption patterns, but there are also very interesting technological advances that are coming up and that could free up a lot of land. I mean, synthetic meat at the moment is still very energy intensive, but it'll be interesting to see how that develops. And in some cases that there are technologies like that might be very useful.
And one very quick addition to Cecily's point and Pete, so just fully agree with what they've said. And I think it's important to remember that what we've been talking about in this session is what I think of as sort of the supply side of the story for ecosystem-based climate mitigation. There's the demand. So what we're talking about with diet is the demand side, right? So what is it that many of us live in urban areas and do not have sort of direct engagement with land management decisions. But this is a huge one, right? So what we choose to eat has a huge influence on land use, and this question of the availability of essentially spare land. So given the absence of sort of spare land, as Simon pointed out, one of the major ways of releasing land is through particularly livestock, right? Particularly the ruminant gut, right, is essentially the most inefficient way of producing food from plants. So agreeing with everything that's been said.
Okay, great. Okay, I think we're coming towards the end of this session. So first I'd like to thank all of the speakers for their excellent presentations and for navigating the challenges of doing this symposium by Zoom, which always has technical challenges, but thanks for keeping on time and being very smooth in delivery. Thank you to all the people who posted questions. I think we've had well over 70 questions come through, and inevitably we couldn't really address most of them. The nature-based solutions team say that they will try and address many of them directly. So your questions will try and be a response to them later on. I see Pete has also offered to address directly any questions that have been addressed to him. Maybe some of the other panelists may want to look at ones that are specifically addressed to them and post a response that we can circulate to everyone. So thank you everyone for this really fascinating and stimulating session. A reminder that there's a break now, and the next session starts in 1 hour at 3:30 p.m. British summertime, and that will be with a different web link that you should have received if you want to participate in that session. So thank you everyone, and goodbye.
Thank you.